Okay, welcome back juniors. This is your lecture 1.1 and this 1.1 denotes your first lesson, that's laws of motion, and that point 1 denotes the lecture. That is, this is the first lecture of your laws of motion lesson. Now we are going to start with this chapter, and if you had seen your class 9th book, there might be a lesson called as motion, and that lesson is correlated with this lesson, laws of motion. So first of all, let us see what we will be getting after reading this topic, this lesson. Learning objectives. Okay, understand the concepts of force and motion. Okay, there is nothing to explain in this line. We'll be understanding about force and motion, and then explain inertia and its types. First of all, after completing this inertia topic, then after that you will start realizing that each and everything is happening somewhat, or it is correlated somewhat with inertia. When you're traveling in a moving bus and you're sitting in your seat, and if the driver applies sudden brake, you'll be falling, or you'll be just moving frontward, and there inertia comes into action. So after completing this inertia topic, we will be knowing more deeply about what is happening in that moving bus. And then state the three laws of motion. Newton's laws of motion. This will be on fire when you are studying 11th and 12th. This is a great headache, and it will just twist your brain. These three laws, just the three laws will twist your brain like something. And then these laws application will be taught here, and later on we will be seeing about what is force, what is momentum, and what is impulse. More or less, momentum, impulse, and force are just interrelated with each other. We'll be knowing it soon. And then distinguishing between mass and weight. Well, right now the students and the viewers who are seeing this video, most of you might be knowing that mass and weight, or both of them, or more or less same things, but this topic will say you what is the difference between mass and what is the difference between weight. So basically these two things are very different from each other, but due to some language problem, we are thinking that weight and mass are same. So if further someone asks you what's your weight, just say that my mass is this kg, and if they are asking for your weight, just multiply it with 10. So you might be confused with this, but later on we will delete, just leave it now. And then analyze weightlessness and the principle of conservation of momentum. Okay, here comes another law, I guess. Principle of conservation of momentum is a bit good topic, and here we will be dealing with pistol bullet problems and all. And next one is explain the laws of gravitation and its applications. Okay, you might have heard this name gravitation in your 9th class, and what we can say simply is that we are just holding back with our earth in the surface due to gravity. If gravity is not there, we will be just floating in our universe. So gravity plays a major role in our life, man. We must study this so hard. And the next one is understand the variation in small g due to height and depth. Well, what is small g? It's nothing but Earth's gravitational acceleration. Small g is equal to 10 meter per second square. It's commonly known as that, but that g is equal to 10 meter per second square will vary depending upon from which point you are measuring your distance between Earth's center and a point away from it. That's all. This g's value is dependent upon the distance between that point and center of the earth. So we will be doing that in this thing, and finally we will be solving some numerical problems. And I think that we won't be solving more numerical problems because I'll be teaching only the theory part in my lectures. Okay, now coming back to the theory part, and this lecture will be teaching you what is there in this introduction part. From here to here I'll be teaching it, and the next lecture will be starting from 1.1 force and motions. Okay, now going line by line. Human beings also curious about things around them. Things around us are related to one another. Some bodies are at rest and some are in motion. Rest and motion are interrelated. Okay, just if we take for an example, humans and plants are interrelated. We are interdependent. We need O2 and plants need CO2. So we are interdependent. But it's not the case here. Interrelated is different from interdependent. Interrelated is just a relation. Uh, I mean, what can I say is that if you take the relation between you and your mother, there is some interrelation. So the same way here, rest and motion are interrelated. That's all. That's all. There's no hard thing here. And then the next paragraph. In the previous classes, you might have learned about various types of motion, such as linear motion, circular motion, oscillatory motion. Okay. First of all, what is motion? It's just moving something, or the act of movement is called as motion. So simple. So what are the types of motion? There are three types of motion. First one is linear motion, second one is circular motion, third one is oscillatory motion. In class 9th, you must have studied linear motion and circular motion. So oscillatory motion will be taught to you in 11th, I guess. Yeah, 11th. Okay, but here we will be studying more about linear motion and circular motion. So far you have discussed the motion of bodies in terms of their displacement, velocity and acceleration. In this unit, let us investigate the cause of motion. So in 9th, you will be taught that a car is moving, calculate acceleration, and they will be giving some values like velocity, time. So that's what you were doing in 9th, right? In 10th, you will be taught what is the cause of motion, how the car is moving, how the tires are applying force to your car, and how friction is acting on your car. This is how you are going to be taught in this lesson. So be careful with this lesson, a bit tough one. When a body is moving, a question that arises in your mind is what causes the body to move. Similarly, when a moving object comes to rest, you would like to know what brings it to rest. If a moving body, if a moving object speeds up or slows down or changes its direction, what speeds up or slows down the body? What changes the direction of motion? Yeah, we'll be getting so many questions right. Uh, if you are just touching your phone and just moving it some distance away so that you can see the see the phone clearly, so you are applying something, you are doing something so that the phone is moving apart. That's correct na? Take some other example. Okay, if you are just rolling a ball from a place to another, there is something acting on the ball which is making it to move from your initial position to the final position. So that's what we are going to see in this chapter. The next paragraph says one answer for all the above question is force. Yeah, we are applying force on the ball, so the ball is moving. So what is force? It's just a push or pull. We are just pushing the ball now. So that's where force is there. Yeah, we are applying force in the ball is moving. We are applying force on the phone, so the phone is displaced. In a common man's understanding of motion, a body needs a push or a pull to move or bring to rest or change its velocity. Hence, this push or pull is called as force. So, what is force? A simple definition is that a simple definition of force is push or pull of any body to change its motion. That's all. I'm again repeating the definition. Push or pull of a body to change its state of motion is called as force. Okay, now next paragraph. Let us define force in a more scientific manner using the three laws proposed by Sir Isaac Newton. Sir Isaac Newton is a great scientist. He just created those three laws, and those three laws gave path to a wide range of physics which you're studying today. Okay, these laws help you to understand the motion of a body and also to predict the future course of its motion. If you know the force acting before before Newton formulated these three laws of motion, a different perception about the force and motion of bodies prevailed. Let us first look at these ideas and then eventually learn about Newton's laws of motion. So after this introduction, what they are going to give is that they won't be directly going into Newton's laws. First of all, some members might have created or thought something before Newton, that this is force, this is what's happening in our environment. So this book will give you those things before Newton's law. That's what they are saying here. And then now coming back to a good word, mechanics. Most of you might have known this word. Mechanics is the branch of physics that deals with the effect of force on bodies. It is divided into two branches, namely statics and dynamics. Wait for a minute. Okay. Statics and dynamics. Mechanics, you must know this word very well, man. You must understand what this word says. Mechanics is the branch of physics that deals with the effect of force on bodies. See, the same case, take the case of ball, and we are pushing the ball. So what is our effect, or what is the effect on the ball that force is causing? And this study is called as mechanics. So mechanics is divided into two branches, namely statics and dynamics. So first of all, what is statics? It deals with the bodies which are at rest under the action of forces. Take an example. If you are just sitting here, sitting on your chair, you might be knowing that there will be no force is acting on us, but that's wrong. That's actually wrong. Whenever you are doing nothing or whenever you are doing something, gravitational force is always acting on you. Without gravitational force, you can't stand on this earth. So reading about this gravitational force and normal force acting on you is called as statics. When an object is static, or when an object is in rest, and when we deal with that object's force acting and what are the other sort of things, this is called as statics. And what is dynamics? When the same object is moving, and when we are studying the forces acting on the moving body, that is called as dynamics. These two are just vice versa of each other. Okay, I just explained dynamics. Then coming back to kinematics and kinetics. This is quite interesting, man. Your 9th standard is kinematics and your 10th standard is kinetics. That's all I can say. Because kinetic deals with the motion of bodies without considering the cause. So take an example. தமிழில் சொன்னால், இப்போ நீங்கள் ஒரு கார் வச்சுருக்கீங்க. அதாவது 9th வந்து உங்களுக்கு எப்பயுமே ஒரு கார் எடுத்துக்கோங்க. அதோட இனிஷியல் வெலாசிட்டி 0, அதோட ஃபைனல் வெலாசிட்டி 20 மீட்டர் பர் செகண்ட், அண்ட் அதோட டைம் வந்து 2 செகண்ட்ஸ். ஸோ ஃபைண்ட் ஆக்சலரேஷன் அப்படின்னு கேட்டிருப்பாங்க. ஸோ நீங்கள் சும்மா நார்மலாக அதோட அந்த கார் எப்படி மூவ் ஆகுது அப்படிங்கிறதெல்லாம் பற்றி யோசிக்காமல் நீங்கள் டேரெக்டாக ஒரு ஃபார்முலா யூஸ் பண்ணி அதோட ஆக்சலரேஷன் எவ்வளோன்னு கண்டுபிடிச்சிருவீங்க. ஸோ நீங்கள் மற்றதை பற்றி யோசிக்க போகிறதே இல்லை. ஜஸ்ட் டூயிங் ஃபார்முலா அண்ட் திங்கிங் அபவுட் டிஸ்பிளேஸ்மெண்ட், டிஸ்டன்ஸ், வெலாசிட்டி, ஸ்பீட், ஆக்சலரேஷன், டைம், இவ்வளோ தான் நீங்கள் யோசிக்க போகிறீங்க. ஸோ இதெல்லாம் பற்றி யோசித்தா மட்டும்தான் நீங்கள் கைனமெட்டிக்ஸ் அப்படிங்கிற ஒரு டாபிக்குள்ளார இருக்கிறீங்கன்னு அர்த்தம். அதுவே கைனட்டிக்ஸ்னால் அந்த கார் எப்படி மூவ் ஆகுது, அதுக்கு ஃபோர்ஸ் எப்படி அப்ளை பண்ணுறாங்க, அதோட வீல்ஸ் எப்படி ஃப்ரிக்ஷன் க்ரியேட் பண்ணுது, அதோட வீல்ஸ் எப்படி இந்த காரை புஷ் பண்ணுது அப்படின்னு அந்த காஸ், மோஷனோட காஸ் பற்றி படிக்கிறதுக்கு பேர் தான் கைனட்டிக்ஸ். ஸோ so these 4 topics, subtopics are very important, and you must read these definitions for getting good grasp on this topic. So that's all for this lecture 1.1, introduction about laws of motion. So in the next lecture I will be dealing with force and motion. Okay, That's better. In next lecture I will be dealing with force and motion as well as inertia. And final thing is that if you like to share, subscribe or like, do that, but just gain knowledge from my YouTube channel. Thank you.